Now let's take a look at example 3, special powers, and we're going to be looking at particularly when the exponent is 1 or the exponent is 0. Now when the exponent is 1, the answer is just the base. So 4 to the first power means to write the 4 down once. So that's your answer. 4 to the first is 4. 37 to the first is 37. And x to the first, so a variable to the first, is just x, is itself. So whatever number to the first power is always just that number. Now, let's take a look when the exponent is 0. Now, the answer is almost always 1. There is one exception, and that is going to be 0 to the 0 power. So let me show you. If I type in 0 to the 0 power, now that upside down V, or it looks like a triangle, that's the exponent button. So 0 to the 0, I get a domain error message, which means that is not possible. So let me show you what these other ones will be. Most students want to say 8 to the 0 power is 8, or excuse me, is 0, but that is not correct either. But let me show you a few numbers, some examples, to show you how we're going to figure out what the 0 power is. Now in math, we often can figure out an answer based on a pattern that we are noticing. So 2 to the first is 2. 2 squared is 4, 2 to the third is 8, 16, 32, the next one would be 64, and so on. Now, let's reverse the pattern. So instead of finding 2 to the 5th, 2 to the 6th, 2 to the 7th, keeping our pattern going up, let's reverse the pattern to see, okay, I want to know what 2 to the 0 is. That was before 2 to the first, which I know, but I need to go backwards. So if we take a look, when we do exponents going up the patterns, we're going to be multiplying by 2 here. So let's reverse the pattern. So if we reverse it, 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So if I want to figure out the answer right before that, I'm going to do the same thing. And 2 divided by 2 is 1. So 2 to the 0 power is 1. Now this pattern does continue into the negatives, but we do not need to go past 0 at this point. So we know that 3 to the first is 3, 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81, 3 to the fifth is 243, and if I want to find 3 to the sixth, I would multiply that by 3. If I want to reverse the order, I'm going to do the opposite operation. So instead of multiplying, I'm going to divide. So 243 divided by 3 is 81. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. So you'll notice the pattern continues. Any number to the 0 power is 1. Same thing will happen with the 4s. So here I found all the answers to 4 to the first, to the second, to the third, 4 to the fourth, 4 to the fifth. Well, if I reverse that, 1024 divided by 4 is in fact 256. 256 divided by 4 is 64. 64 divided by 4 is 16. 16 divided by 4 is 4. And 4 divided by 4 is 1. So by following this pattern, any number to the 0 power is 1. So 8 to the 0 power is 1. 527 to the 0 power is 1. And the variable y to 0 power is 1. That means any number to the 0 power is 1 with only this exception there.